as well about password generation in wireless routers. I'm really happy to have this talk as well. It's from Eduardo, and I will just allow him to get started right once. There you are.
Can you hear me? Yes. Good. Well, this is the title of the talk today. It's my name, my college, and I'm going to be a little bit fast today. I have like 45 slides, so sorry if I speak really fast. This is the outline for the presentation. We are going to present who we are, the introduction, the methodology that we use, the findings and vulnerabilities in the routers, the conclusion, and questions. This is myself. I'm not a speaker in any conference. It's my first conference. I'm a little bit nervous. I'm a master student at the Carlo Institute. It's a master in computer security in the Netherlands. I'm from Verdult University in Meijer. I'm security analyst at Rescue in Delft. The company is also in the States, in San Francisco. I'm working mainly in satellite devices, so I'm doing security evaluation for hardware. This is my blog, and this is my company right now. These are my colleagues. Maybe if you have messed around with Meijer or iClass or HiTech, maybe you know this guy, Roel Verdult. He's a researcher in Verdult University Nijmegen. And then we have another colleague, Carlo. He's not here today. He's also doing a lot of research in Meijer, how to break the crypto. And he's also a master student like me. Was my colleague during my master, and he's also a PhD. What this talk is about is like a little bit of basic hardware hacking, and how we extract the firmware images from the routers, and how we were able to find out the WPA algorithm to generate the keys. Then we did responsible disclosure with the ISP, so basically they know everything. This is the timeline. I'm not going to go further. You can read it later. And yeah, when you have a vulnerability in hardware, you have to wait for like 6 months or something, and then you can release the vulnerabilities. This talk was supposed to be released at Usenix booth in Washington this week, but Barry invited me also here, so I decided to be here as well. I think it's really cool. I don't want to go in details in this. We are going to release a paper, so you can read the paper, and we explain everything, how WPA works, which algorithm is using internally, how is working the authentication and the authentication. Basically, the authentication, there is a challenge response protocol, and the problem is not here, but the problem is that even if you don't know the key, you can de-authenticate everyone in the network. So that means that you can get the handshakes. The handshakes is the package where the key is. So you can then brute force this packet. So basically, what you can do is that you can be in the middle, you can be the attacker, the adversary, and the communication is encrypted. But you can send a package like, hey, you have to be I want out of the network. So you can send a package, and the package is in plain text, and you can de-authenticate the client. Maybe you can use ACRAC. I think everybody knows ACRAC here, right? Raise your hands if you know ACRAC. Okay, quite a lot. Nice. Not gonna be in details. Well, this is the main thing that you have to do if you want to be sure if the algorithm is in the router itself. You have to extract the firmware image. Sometimes it's really easy, sometimes it's not really easy. So the steps that we did is like, first thing, you go to the website and see if the firmware is there. Normally the firmware is not there because this is managed by the ISPs. The second thing that we can do is like, well, maybe we have a little bit of skills in penetration testing. We can see if we can exploit something and we can get the firmware out. Sometimes this is not working, so we have to go to UART or JTAG. There are hardware protocols, and if nothing works, we can always extract the memory flash and get the content out. Basically, this is an example, command injection in one of the routers. Yeah, you have telnet, you don't have many commands, and suddenly you can execute commands in the cell, so you can escape the jail. This is really common, really common. Seriously, this is, for example, you were not able to extract the firmware for a command injection, like here. you can, for example, communicate with your protocol. It's a serial protocol, and there are 3 cables, GND, TX, and RX, and you can try to extract the firmware over here. Sometimes this is protected. Basically, all the times it's protected, so you can go further, and you can, for example, try to JTAG the device. To try to JTAG the device, there is always like 2, this is, for example, JTAG. It was not here, so I solder some pins here, and then I communicate with the board. And when you are using JTAG, JTAG is under the operating system and the firmware itself. So you are basically a really, really low hardware level. So you can say, hey, I want to extract the RAM, I want to read the flash, and it's really, really cool. If nothing works, you can always use an EEPROM reader, and you can get the content out. This is mainly we did because most of the routers, they were not able to command injections, or the URI was always with password, and some boards they were not using JTAG. So basically, we dumped the firmware. Let's go for the manufacturers. We start with Comtrend. This is really common in Spain and also in the Netherlands. That is the countries that I live. These are the findings. I'm going only to discuss 2, like one backdoor, where there are different backdoors, and the WPA generation key. This also, for example, how we could extract the firmware. So we basically use open WRT into RAM, and then we enable telnet. We found the command injection. We've done the firmware as well. We've also found the buffer overflows, but this is not important here. Let's go for the backdoors. No, I need water. Basically, when we done the firmware, we were able to do a little bit of reverse engineering. So we realized, like, okay, this looks like there are 2 users, and sometimes here you have admin here, and if you are checking the access mode, and if the user is this user, you are totally admin, because we were using this router, and you don't have all the features in the web interface. So basically, we discovered this, and this is too bad because it cannot be changed by the customer, it cannot be changed by the ISP without the firmware update. And it's not plain text. It's in plain text. It's not hash. So if you have the firmware, you know that this is totally secret and you can access. This is how we realized that it was here the command injection. So it's checking the ampersand, it's checking the semicolon, but what about the pipe? What about the quotes? So it was too easy. It was really common. Let's go for the algorithm. We were able, once we enabled the telnet, because it was not enabled by default, we were able to see one command here. Well, you have like 6 commands, like version, and MD5 WPA key, blah, blah, blah. And we realized, okay, we have to follow this, we have to track this command. This is, as you see here, is a client shell, but it's really constrained shell. We realized that there is an MD5 dumping content from an MD5 encode to result, and then it's printing the WPA key. So we know already that it's MD5. Nice. We can go a little bit further, and we see here something really nice. This looks like a MAC address and another thing, and we realized that it was a secret. It was the LAN MAC address, and this was the wireless one, or I don't remember which one. And then all this string is going to MD5 encode, and then we realize this is plain text, this is ciphertext, and if we go a little bit further, then they are removing, before, when they create this, the password, they remove it. So the question is, what about if I patch the firmware and I put LS? So that means that you can recover the plain text, and we did it, and it was working. And how we can get, for example, how we can read this MD5 encode, because we use the command injection that I showed you before, so we were able to see basically the plain text for the algorithm. This is to summarize. This is the constancy that you see. This is the lowercase, the uppercase, and now we have 2 things if we want to break into the network. So we can brute force 3 bytes that we don't know, so we can use GPUs. It's pretty fast. Or we can do it even better. So if we can have monitor mode, we can see the packets in the network, and we realize that the headers are the MAC address in the wireless MAC address and the LAN MAC address, so we can get all the data we need. And it was basically, if you have monitor mode, it's seconds. This is about some minutes, so you can recover the keys. It's really easy. This problem, it was not only in the Netherlands. In 2015, it was also in Spain. I found the same algorithm. It was even worse, because it was the same command injection. Well, they didn't patch the ampersand yet, so it was really funny. And here it was you were not able to use ls. So what I did is a for with echo. So I was able to echo all the files with a loop. So it was a homemade ls. So I found it that, okay, there is something here really interesting, so I also recovered the algorithm. Basically the same strings, different secret. This is the Comtrend debug mode, the password, so yeah. Let's go for another brand. This is really popular in the Netherlands. Mainly, if you go to a store, you only can buy this, like a brand. It's really popular. When we start with the research, many people, they were, when we start with the research, 2 people from Italy, they released some stuff, so it was not really interesting for us anymore. So, well, I read it, and I followed a little bit what we're doing. They also found backdoors, they also find some algorithms, firmware obfuscation. They were using just XOR encryption. So it was really funny, because at the end of the firmware image, it was everything zeros. So if you do XOR with zeros, you know what you get, the key in plain text. So it was really cool. So when you get the key, you can disobfuscate the firmware, and everything is in plain text. And let's go for there. Our findings. We found a new algorithm. We confirmed that the old algorithm, it was working in many routers, maybe 90% of the routers of this brand. And we also reverse engineered another binary. The first binary that we did, it was just a binary, and it was in the binary folder. It was called auto WPA key. So even if you are using chroot and you are using KeyEmu, you can emulate it, and you are inside of the emulation, so you can use the libraries that they are in the jail. So basically, you can get the key in plain text as well. So it was really funny. So I started doing reverse engineering, and it was this binary. It was totally stripped, so that means that you have no symbols in the binary. And this is the last version I did. It was MD5, as you see here. But I didn't know, so I reversed the whole MD5 algorithm. It took me like 5 days in the midst. It was really cool. And yeah, well, at the end you learn. If you see some constants in the binary, maybe they are using MD5, SA1, SA256. It was really cool. This was they were using the old algorithm that the Italian guys they released, and they were using another charset here. So basically, it's like 40% of the routers they are using this charset, and the other ones they are using this one. Around 40 models they are affected. This is also, well, we didn't focus on the WPA2 generation, but as you see here, it's always generated by the MAC address. So the MAC address is always public, so you can recover it as well. We didn't pay attention to this, it was too easy. We went for Thomsom. Someone here remembers Verdult in 2008? So we have the same problem again. Thomsom, same manufacturer again. We struck one image, and we realized, well, now here is, I renamed all the functions, but it was totally stripped. So this is a function that is generating all the wireless network names for from the serial number. So there are like 8 ISPs from Argentina, Spain, Holland, Austria, Poland, I don't know. This is, for example, one example. I don't know where they are from. They are not in the Netherlands right now. This is, for example, the switch that we found for all the WPA keys that they are generating here. So I started renaming. For example, I have no idea which model is this because it was not the strings, and another here that I removed because I don't want to release the ISP names. Basically, we really focus on the model in the Netherlands because it's the router that we use every day at home. So basically, we quickly found that like, hey, this is format with the name, with the format of the SSID. We found the algorithm. We found that it was a public hidden SSID, that it was from 3, 4, 5 years ago, and nobody knew that. And then it was with a hardcode password, and it was really funny as well. And basically, this is all the operations that they are doing. And basically, you see the char set. They are loading the A, and this is I think this is the length. Yeah, this is the length. So you have basically a lot of information here. So we reverse this. Even if you don't know what it's doing, you can convert assembly code to high-level code in C or Python, and you can do the same stuff. This is more examples for more countries. We don't know which countries they are, and yeah, basically they have a function, and this function is calling another function, is generate the hash. This was totally stripped as well, so we were renaming names. For example, here is like, I don't know what is this, but it's very used. That's good. And then I realized it was a string copy, because he was copying here. He was writing in the string here. And yeah, I'm going to show now some examples. MD5 as well, model, symbols, that they are these symbols, that they are a little bit difficult to brute force. And also the serial number here. So basically the serial number is a numerical number of 9 digits. So it's pretty much always consecutive, so you can really brute force it. Another example, I don't remember which country is this, always the same, MD5, model, ISP, serial number. Another one here, they were generating the hash, and they are doing some calculations later to modify a little bit. Another one here. It looks like they are the same, but they are not the same. They are using different names, but basically the algorithm is the same. Arcadyan, they are doing a little bit obfuscation in the firmware, so sometimes you have to struggle a little bit to recover the firmware in plaintext. And when I did this, I work in this in number 2 in Spain for Seguridad Wireless. So we recovered also the algorithm for Arcadyan. They are using just XOR and ANDs and normal additions. And basically, this is it was in Spain. It was also in Germany, and now it's in the Netherlands. It can be in more countries, so it maybe also here. I mean, it depends on the ISP. So, and 4 minutes, enough. Only for a slide. I'm gonna drink a little bit. This is not in the Netherlands, but this is also another firmware that I was paying attention. Sometimes when even, I mean, the binary itself, the firmware image is not stripped. You can see really fast, like, okay, this is the function, generate key from Mac, and they are using SHA-1 256. So it's really straightforward to reverse engineering the firmware. This is, if we are here, we can go here and, yeah, generate key. And this is the function that is creating all the default settings. So yeah, we can in a little bit know that this function is calling to create WPA fast from key, and then it's converting. It's doing some conversion. And if we go a little bit further, a little bit deeper, we can see the function and generate key is taking one argument before calling the function. And then it's here, it's loading the address of the passphrase, the address of the key, where it's going to write the key, and then it's jumping there, so we jump there. And here you basically, really fast, you see like, hey, this is SHA 256. We know that it was something that it was coming before, it was the first argument. We have some value at this address that has this length, it has 20 bytes. 20 bytes in X, that is 32 bytes, sorry. And then we have something here, it's load immediate in the register A2, 6 can be the MAC address. So if we go there, we see something here, this is the address that I was talking about before. So basically here we have 32 bytes, that they are the secret seed, so the secret, the magic number that they use to generate the key. And then we have also the charge at the bottom. The conclusion is like the things they are they are really terrible in security about routers. They don't use much security. They don't pay attention, and this is not only a problem in the Netherlands and in Spain, the country I was living, and I'm native there. So maybe this is a problem that it can be everywhere. So with this research, we want to invite people to do the same in your countries, and maybe we can do the same. Nice. Security by obscurity doesn't work. I mean, if you don't release the algorithm and you think that you are totally secure and your clients are secure, it can be in the other way around. So security by obscurity is not security. Actually, my mentors say that if you have security by obscurity and you subtract security, you have no security. So another conclusion is like vendors, they reuse the same algorithm with slightly small differences. So the same thing I found in Spain was 5 years later in Netherlands. The same problem I found here in I think it was in Argentina. It was in Portugal, and I think it's another country like Poland. Another guy sent me an email, but yeah, I don't have time for that. So it looks like they are using the same, always the same. So yeah. Even if the binary is stripped or it's not, I mean, if it's not stripped and it's not obfuscated, it's still doable. It's not a solution. Just strip the binary and think that you are secure. Second. And the other thing is like the ISPs, they have to include the algorithm itself in the firmware. And with this, I think I'm done. Thank you for your attention. And if you have questions, go ahead. Okay.
First. Yes.
Other than the backdoors, why are they trying to securitize?
Why they try?
Yeah.
Because they have, I mean, now they have TR69, this has remote protocol, so they have totally access to your router. But I don't know which this firmware, the year, I don't know where they installed this backdoor in the router. But maybe like some years ago, this protocol it was not available for all the ISPs, so it's some way to have control to your router. I think it's for that. Yeah.
Forgive me if I didn't get it covered. How is it getting the firmware? So I know you were driving them straight off the yours there. Exactly how are you getting theirs? In other words, were you buying the same hardware routers and then doing this, or how are you getting the ISPs?
How can I start it? How I did to start the firmware, you mean? Okay. Well, we bought a bunch of routers.
So you bought the same router?
Yeah. Of course. That's what okay. We went to eBay and we bought the second-hand routers, and then we did this.
Oh, you were actually buying their routers from eBay?
Well, not eBay. It's another website. Second-hand.
Okay. So we have to break it off. 3 more minutes, and we actually have Devin.